today we are learning chapter 3 under this laws of motion, inertia. Let us see this what is inertia, how it is. So first we should observe this one activity. There is a bottle. This is the bottle, and just above this bottle arrange one paper hood. This is the paper hood. So a disc shaped a thick paper cord. A cord is cut and arranged in vertical position. Just above this arrange one pen cap. Arrange one pen cap. So now just you remove this paper hood suddenly by using some force. By using some force, just remove this paper hood. What happens? When remove the paper hood, so this, what do you call, paper cap, pen cap, just fall into the bottle. What is the reason? At the time of the incident, applying the force, with that net force, the paper hood comes out, just get into motion. At that instant get into motion, this pen still remain in the resting state. So now once this is removed from the place just by making some motion, then the one which is missed, the paper, the pen cap which is in rest, just fall into the bottle because of the gravity force. So here this is because of the inertia. So means here what is the inertia? Just the object is resist to oppose the change in its state. So that opposing character, the resisting property, is generally we are calling inertia. Second, another one is, first in the carrom board also we did one. So in the carrom board you find there is a stack of coins. Just you see the stack of coins, one above the other. Now take one striker. This is called striker. So the striker used to strike the bottom coin. What happens? The coin get in motion. The coin is removed from the bottom. Then the remaining coins in the stack, they fall down. Or sometimes the bottom coin is replaced by the striker. In that case, the stack remains as it is. So this also indicates why, because the bottom coin will get into motion, the other coins in the stack remains in the resting state. So they remains as it is. So at the bottom, the gap created by the motion of the bottom coin is occupied by the striker. Therefore, the coins stack remains as it is in the pile. But if the striker is not occupying the space created by the bottom coin, which get into motion, the stack fall down. So that is so this also indicates that why this at the instant the bottom coin get into motion, the remaining coins are still in the resting state. So because of that, so the bottom coin is removed by this striker by applying some force instantly. So the remaining coins, they fall down because of inertia. So now let us see another one. So bottom coin will be removed from the stack and the other coins in the stack will slide down. Means they fall down, they slide down because of the gravity force, of course. So now next one is same thing. You can see another activity, another observation. When a bus which is at rest, a bus which is rest, the passengers are sitting in their places in the seat. So what happens? Suddenly the bus get into motion. The bus get into motion. What happens? So these persons, the passengers, they feel that, they observe, they experience that their body is sticking to the backward direction to the seat. So this indicates at the instant of the bus get into motion, the passenger's body still remain in the resting state. Because of that, they are sticking to the seat. So then what happens here? Suddenly stop. Yes. Now second one is when the bus is suddenly stopped by applying some brakes. What happens? In that case, the passengers are in the motion along with the bus. But if the bus get into rest at that instant, the passengers still remain in the motion. They remain in the motion state. Therefore, these passengers are falling in the forward direction. This is also nothing but inertia. So inertia here, what is saying? Even the bus is stopping, the body of the passengers are resisting to oppose the stopping. That's why they are falling in forward direction. In the first case, what is there? When the bus get into motion, still the passenger's body at rest, they also resist, the body resist to oppose the body get into motion. So this opposing property of the object from rest to the motion or from motion into rest is called inertia. So the change can be described only with the help of the inertia. So that change can be described with the help of the inertia. So simple language we can say that inertia means accepting the change is not correct, is not accepting. So the inertia simply means not accepting the change, means the body in rest not accept to enter into motion, a body in motion not accepting to enter into rest. So that not accepting to change its state, that character, that property is called inertia. So let us see the another one. If the bus is stopped suddenly, what happens? If the bus is stopped suddenly, the body of the passengers still in motion. So their body resists to oppose the body get into rest. That's why they are falling in forward direction. Now another case, what is saying? When the bus suddenly started, the passenger's body still in rest. So the body resists to oppose get into motion. So this opposing property to change their state, means state either rest or in motion, is called inertia. So inertia means not accepting the change in their state or opposing to change their state. That property is called inertia. That property is called inertia. So let us consider a football placed at rest on the ground. So the law of inertia tells us that football will remain in the same state unless some external force acting on it, some net force acting on it. So a football placed on the ground, it is at rest. So it remains at rest only as long as the external force is not acting. If the external force is applied, then the body get into change of state. So let us see this one. Now the ball, if the ball will fly in the, just when we kick the ball fly into the air in the direction of the kick. In what we are kicking, the ball fly in the air. So what happens with certain speed? When we kick by applying some force, the ball starts get into motion with certain speed. So until a force slows down. So then what happens? then gradually that speed is gradually decreasing and slows down or ultimately stops. Slows down or always stops it. Why? Because of the gravity force acting opposite to the applied force. Because of the gravity force is acting on the ball, opposing the force applied by the persons who was kicked the ball. If the ball went high, what happens? The force of gravity slows down. The force of gravity slows down. So what happens? The body comes to stop. If the ball rolls on the ground, suppose you kick the ball is rolling on the surface of the ground. What happens? After covering some distance, the ball comes to rest. Because what? Because of the effect of the frictional force in the opposite direction. So in the first case, the flying ball ultimately get to stop because of the effect of gravity force. And when the rolling ball on surface of the ground stops at a certain distance because of the effect of the frictional force. So because of these two forces, what happens? They ultimately comes to stop. So they cannot move indefinitely. They cannot move indefinitely because there is some external force is acting opposite direction. So when you compare this one, in any ball either rest or in motion is affected by a set of forces, not a single force, a set of forces. If the set of forces, the vector sum of all the forces is called net force. If the net force is acting on a object, the object get into motion in the direction of the net force, in the direction of net force. If the net force comes to 0, that indicates the object remains in the same state. Means if the net force 0, the object is at rest, remains at rest. Now, if the net force is 0, the object is in motion in that instant, the object remains in the motion only. So that means the net force then, velocity of the object is either 0 or may constant. If the velocity is 0, when the net force is 0, what happens? The object is either at rest or in motion. So that means the velocity change is 0. So when the net force acting on a body is 0, when a net force acting on a body, net force means the frictional force or the gravity force or the normal force or the applied external force, the sum of all these forces which are acting on an object is taken as the net force. If the net force is 0, what happens? We say that the body is in equilibrium state. It means the body in rest remains in the rest because of equilibrium. If the body is in motion, remains in the motion in that state. So there is now understanding inertia. Inertia means the property of the object to oppose the change in its state. Change in its state. That opposing or resisting property to resist the change in its state, either rest or in motion, is called inertia. So this inertia has some relation with the mass. If the mass of the object increases, the property of inertia increases. The property inertia increases. Say for example, when a bus is moving and a bicycle is moving in the same direction with the same speed, which has greater inertia? The bus has greater inertia than bicycle. Why? Because while they are moving, suddenly stop the applied force. So then what happens? The net force comes to 0. Now you find the bus in motion remains in motion, the bicycle in motion remains in motion, but after some distance passing, the bus comes to stop because of the frictional force, and the bicycle is also come to rest after some distance. When compare these two, the bus comes to stop in a small distance because of greater inertia. It has a greater mass, whereas the bicycle has less mass, same speed, therefore takes more distance to get to stop because of the less inertia. So greater the mass, greater is the inertia. Greater the mass, greater is it. Do all the bodies have the same inertia? No. All bodies are not having same inertia. They have different inertia because they related with mass. So different bodies have different masses, have different inertia. So which is easy for you to push a bicycle or car? Bicycle, because inertia of the bicycle is very less than the inertia of the car. Therefore, when the inertia is less, that needs less net force to get into motion or to stop. When the mass is greater, that requires greater net force to stop or to get into motion. So it is difficult. Why it is difficult to push a car? Because the car has greater inertia. We say car has greater inertia than the bicycle because car has greater mass compared to in relative to the bicycle. Why does the car possess the more inertia than bicycle? Because the car has greater mass and it requires the more net force to limit the inertia. It means to cross the inertia. Inertia is a property. What is inertia means? Inertia is a property of matter that resists the change in its state of motion or in its state of rest. So inertia is nothing but what? Inertia is nothing but a property of and with that property of what? Property of matter, which is mass. So that matter means that property helps to resist the change in its state of motion or in a state of rest. So mass of an object is considered as the measure of inertia. So since inertia depends on mass, greater the mass, greater the inertia. Lesser the mass, lesser the inertia. So therefore, inertia can be measured by measuring the mass of the object. Therefore, what is saying? SI unit of the mass is kilograms. Therefore, inertia is also represented in kilograms. So, pushing two wooden boxes. Let us see one activity to support this. Now, take one horizontal scale and two wooden blocks. Here, this is the horizontal scale, and take two wooden blocks. Here is the one wooden block. Do like this. Okay. This is the scale, and here is a one wooden block. And here there is another wooden block. Here the mass is greater. If the mass is greater, here the mass is less. Here the mass is lesser. When you apply the force equally, means some force acting is in, and here same force is acting. Both are influenced by same force. Whenever same force, what happens? It is just moving a small distance. It is moving a small distance. But this is moving more distance. This is moving more distance. Why? So the applied force is equal, but this is covered more distance and that is covered less distance. Why? Because of greater mass, it has a greater inertia. Because of less mass, lesser inertia. So it is covered more distance because less inertia. Because of less inertia. Here is a greater inertia. Because of greater inertia, the wooden block with a greater mass covered less distance. Because of less inertia, the wooden block with less mass covered more distance. So this proves that inertia depends on mass. Inertia is directly proportional to mass. Correct? Inertia is directly proportional to mass. Means greater the mass, greater the inertia. Lesser the mass, lesser the inertia. So from this example, we can conclude that some objects have more inertia than the other objects. Why? The mass is a property of the object. So that specifies the how much inertia the object has. Understand? Mass is a property of an object. Mass is also one of the character of the object. And that mass specifies how much inertia the object has. That means since the mass is directly proportional to inertia, when the mass increases, the inertia is also increasing. So therefore, mass is a property of the object and inertia is also a property of the object. That means mass determines the magnitude of inertia, that determines the resisting property of the object to oppose to change in its state. So that is the answer we can conclude. So what we did, we take two regular wooden blocks. One has greater mass, another is a lesser mass. So both the wooden blocks are touching with a scale. With the help of the scale, we apply the force and the force affecting equally on the two blocks. The wooden block which has a greater mass is covered less distance. The wooden block with a lesser mass covered more distance because the wooden block with a greater mass has greater inertia. So therefore, that is covered less distance. Whereas the wooden block lesser mass has lesser inertia, therefore it resists to oppose the changes less, so it is covered more distance. So that is this indicates inertia depends on matter of the object, mass of the object. So there is a relation between the inertia and mass. So inertia is directly proportional to mass of the object. So next one is a body has a mass m is kept on the horizontal floor and it is pushed in the horizontal direction with a force of 10 newtons continuously so that it moves steadily. When you draw the free body diagram, the body showing all these forces, one is called the normal force, second is the weight force acting downward, normal force acting upward. Then the applied force acting, that is 10 newtons acting in a forward direction. Then some frictional force acting in opposite direction. So because of all these forces, there is some net force acting on the object. So given that the body is moving steadily because of the net force acting on the object, hence the net force on the body is, if the net force acting on the body is 0, so both in horizontal and vertical direction, the force acting on it along the horizontal directions forces are the frictional force and the applied force. So therefore, frictional force equal to the applied force, then the body remains in the same state. What is the state? if the body already in the resting state remains in the rest. If body already in motion remains in motion. Hence, the value of force friction is 10 newtons. The value of the frictional force how much? 10 newtons. That is the answer. So ultimately, what is the inertia? Inertia comes under which law? That is under the laws of motion. We are called three laws: Newton's first law, Newton's second law, Newton's third law. Newton's first law is called law of inertia. Newton's first law is called law of inertia. Why it is called law of inertia? Because the inertia is the property with which the object resists to change in its state. So with this property resisting the object to change its state, that means the resting body opposing to get into motion, moving body opposing to get into rest. So that opposing, resisting property is called inertia. It is explained under the first law. It is called Newton's first law, also called law of inertia. Law of inertia means when the body remains in its state of rest or in motion unless until external force or the net force acting on it. The net force act means when the net force acting on the object, so the object overcome the resisting property, so they get into change in the state. If the net force is not acting, if the net force 0, there you find the object remains in the same state, it can resist this. How much is resisting? The minimum resisting force is called inertia. That you can write. Hence, the value of the force of friction is nothing but the minimum force required to remain, to resist the change in its state. So that is called frictional force. So let us, here is the there is an object, is a free body diagram. Here there is a downward force, means weight force. The mass has some weight. The weight is acting in the downward direction due to the gravity force. There is some force acting upward direction is called normal force. That force is called normal force. Normal force acting upward direction is a supporting force. Then this is the applied force on the object. So there is some force acting at this surface is called frictional force. Now, weight force is equal to the normal force. These two are equal. Now, in this case, applied force is equal to 10 newtons. Now, the applied force is also equal to frictional force in opposite direction. So, therefore, the frictional force is equal to how much? 10 newtons. So we can find frictional force 10 newtons because the body still remains. The net force is 0. When the net force is 0, the body remains in the state of rest. In that case, you find weight force equal to normal force. Applied force is equal to the frictional force. All are equal. Therefore, the net force is equal to 0. So, when the net force is 0, by applying the external force is 10 newtons, then the friction is also equal to 10 newtons. So, therefore, frictional force is acting on the body is equal to 10 newtons. This is the according Newton's first law. So, by using this Newton's first law, we can determine the magnitude of the inertia and magnitude of the frictional force. Magnitude of the frictional force acting on an object. So that is the answer you can write. So ultimately, what is the simple method? Inertia means it is the property of the object to resist or to oppose the change in state of rest or in a state of motion. So that is called inertia. So this property is explained by the Newton's first law. That's why Newton's first law is called law of inertia. So this inertia depends on which property? The inertia depends on mass property of mass of an object. So the greater the mass of the object, greater is the inertia. When you compare the bus and bicycle, the bus has greater mass, so it has greater inertia, and bicycle has less mass, less inertia. Therefore, we can make the bus to get into motion requires more external force. Net force is more required because of greater inertia. So we'll continue this next class remaining Newton's second law. Newton's second law. So Newton's first law, Newton's second law, we can do it tomorrow. Okay, thank you.